Matt. I'm going to talk about how Coink, our project group, over there, is using service-oriented architecture. And so first, what is a service? So it is simply a section of your code, usually a disjoint chunk of code that is dedicated to doing one thing well. And in service-oriented architecture, you break off this chunk into a server, and the only interface you have with this service is through some sort of networking protocol. And so service-oriented architecture is simply using these servers to really enforce good object-oriented design. You have loose coupling because you only have a networking interface to communicate between sections of your application. You have high cohesion because all of the similar functionality is combined into a service. And then your main application, as you'll see later in our kind of system architecture, is just composed of all these services. So you don't have a lot of inheritance, which people usually frown upon in object-oriented design. So one thing that we use is Apache Thrift to kind of facilitate the service communication. And so what it does is you define a Thrift file, which is basically your interface for a service. It gives you functions, types, and exceptions, among other things, but these are really the big three. And the nice thing about Thrift is that when you write up this Thrift file, it will generate a lot of the client and server boilerplate. So for example, we're using it in Python, but you can use it in like between 10 or 20 languages. And it'll generate Python classes that already do the networking communication for us. So really, the services are just class function calls as far as I'm concerned as a Thrift user. And so here's an example of a Thrift file. There's a lot of code on here. What's important is you're seeing we're defining structs, which are just object type things, exceptions, and then the functions that our service has to implement. And so it's all typed nicely. There's these Thrift types and exceptions, really pretty analogous to a Java interface or anything you'd be familiar with. And so here's our actual architecture. So what we have three main services. We have what's called wallet service, exchange service, and then auth service. And so what they do for as far as architecture isn't that important, but what matters is that all of our logic is in these services, and they act as their own server. They're completely separate from the rest of our application, and they have some backend, some database, some implementation that the API or the web client doesn't know about, doesn't care about. All they know is that they have this Thrift interface that they can communicate through, and then from the web client, it'll just talk to the API via HTTP, JSON type stuff. And so what's really nice is that, like I mentioned, they're completely disjoint, separated, and yeah, I mean, it's really just a great architecture because you really can't program to any implementations. You don't know any implementation details, and really the services don't need to be in the same language or not at all related. So really it enforces this really good modular code. And so here's an example of actually using one of these services. This is the wallet service, and this is how you delete a wallet that's associated with a user. It's really simple. So we have the three main things. We have the Thrift generated class, which I store as some object in our application. I'm working on the web API, and so the web API has a wallet client object that fulfills the Thrift interface and talks to our actual wallet implementation. And so you see that you can call this method that was defined in the Thrift file I showed you earlier, and if it works, great. If not, you get this Thrift defined exception, and you go from there. So you see that it's really easy to use, and that a lot of the networking boilerplate is abstracted away from you, and you get this nice, clean code. And so another great thing about the service-oriented architecture is that testing is extremely easy, because each of these services has this really well-defined API that is our Thrift file, and the interface is clean. There's no access to the implementation. And so what I did as the lead on the web API was I wrote up mock services for wallets, exchanges, and auth. And all they are some really simple hard-coded values that fulfill the Thrift interface. So when I call a get, to the wallet service, it'll just return the same thing over and over again. There's no real functionality, but the fact that it's fulfilling this interface allows me to test the web API comprehensively, and the service-oriented architecture really lends itself to creating mock objects and really large-scale testing. And so, last thing, just about done, I just wanted to mention some of the technologies and tools we're using, other resources, if you guys are curious about this. We're using Docker to actually build our services inside of, and that just provides containers that you can deploy many instances of the same service, and so theoretically this would scale very nicely. Vagrant's got a great development environment. It's just a virtual machine with a little bit of extra bonuses. Like I talked about, Thrift is really driving our service-oriented architecture and all the communication between that. And so because all of the logic is based on these services and not actually in our main application, the API, or in the web client, we ended up using Flask RESTful, which is a Python micro web framework, and it's really light, easy to use, and it's simple enough that it doesn't encourage putting logic into your API, which is consistent with this service-oriented architecture. Finally, apiaries we've been using for API design, and something I didn't really talk about, but it actually mocks the API so that web client can test without depending on an API implementation. And then as far as the front end goes, our front end team has been making a single page app which just prevents the structure of our application from relying on the structure of our API. And what inspired us to use all these technologies was this really cool Twitter talk. And I have a link to it here. These are all links to the websites for these technologies. So if you're interested, I'll have Rick post these slides somewhere and you can go ahead and look into these further. But that's everything.